Hello and welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Today I'm with Tom Miles, CTO over at AI&C. Welcome, Tom. How are you?
Hi, Alan. I'm good. Great to be here.
So as we were discussing, of course, before and way before we started recording this episode, your company is doing basically 100% Rust on everything. Is that right?
Yeah, everything from web to backend services. Actually, somewhat on the advice of this podcast, we've started using Spin for microservices, which is excellent. Highly recommended.
I think a new version of Spin just came out because I got a notification from Reddit about it. What exactly is Spin?
Basically, it's a replacement type thing for Kubernetes built on WebAssembly. Anything compiles to WebAssembly. So not just Rust. You can deploy in that, and I think the whole core value proposition is scaling to zero, which is really good for us because it means that we can mitigate costs. We're a very small company still, so there's that. Obviously, with everything being written in Rust, it is a very nice fit because Rust has excellent tooling around that sort of side of the ecosystem.
Now, how long have you been with the company for? Because I'd like to kind of hear a little bit of the history and how you guys got into Rust.
Yeah, so I'm one of three co-founders. We started in 2020 as not a software company at all, actually. We were a manufacturing company making parts for other companies that needed things made, super small, running our own machine, actually, which was fully designed from scratch. I've got a background in mechatronics engineering, so does one of the other co-founders. So we decided basically straight out of uni, out of our masters, to go and become a machine shop. And that sort of morphed to where we are now, which is building software for engineers to help them design parts that can be manufactured. So yeah, that started in 2020 and it's 23 now. So
I was just kind of curious. Was this like a yak shaving kind of thing where it's like you needed to scratch your own itch and found out that everybody else is itching in the same spot?
a little bit. So between undergrad and masters, I was working at a tech startup that's doing computer vision stuff and has some hardware aspects to that. And I was designing parts to get made for that hardware stuff as sort of an engineer. And there was big problems with, I was inexperienced. I think, their first employee. I started as an intern and then sort of stayed on for another 6 months before I went back to uni. And there were just sort of these issues that I was having getting stuff made with the lack of experience I had that I thought this really shouldn't be a problem. So that was what led us to starting the machine shop. I was like, we're going to make it so that people in the position I was in at small companies that need to get prototypes made, need to eventually go to scale, can get that made locally without having to go to China and sign contracts where you've got 10,000 parts minimum once you get to production scale, because that was a pretty early stage startup at the time. We didn't really have the bandwidth to be able to sign those sort of contracts, so we needed stuff made locally, and there was just a need we saw there. It turns out you can design a machine tool, you can build it from scratch, doesn't mean you can run it, which was, I guess, the biggest oversight we had at the time. So we, realizing that, set out to make that problem easier for all machine shops. So I guess at the end of the day, the core belief we have is that it should be possible for the shops locally, wherever you are in the world, whether it's Australia, whether it's China, whether it's the US, Europe, doesn't matter. If you're a small machine shop, you should be able to compete with these mass manufacturers with technology, because it's called advanced manufacturing, but it actually turns out that there's a lot of things that are not as advanced as you'd think, and we definitely didn't think we would have such a hard time. So that's why we pivoted, and that's sort of our key focus at the end of the day, is making it possible for these smaller businesses to compete locally against the big players worldwide.
Oh, yeah. That's a really hard business because, if you have an online SaaS-based company, it's really relatively easy to compete, right? Because we're all about the same, except for if you have, I forget what that thing was in US with the FCC or FTC or whatever, where they're trying to be able to let people limit bandwidth. If you remember, I forget what the heck that one's called, but basically everybody's on a level playing field, right? You can make your website look really, really nice, which is, a lot of these big guys don't have very nice websites to begin with. So you almost have a better advantage at times. But yeah, for manufacturing, like you said, you can, it's hard to, like when you build a prototype, it's much more expensive than building the final one because you have that MOQ, right?
Yeah.
To deal with that.
Yeah, and at the end of the day, these smaller shops that are able to facilitate this small volume sort of manufacturing, they've got the same machines or broadly the same type of machines that everyone has, whether you've got 100 of them or two, which really in our mind, we think that that should mean you should be able to, obviously you're never going to match the volume, but you should be able to be priced around the same as if you were getting 100,000 parts made regardless. But there's way too much human expertise required at the moment, which is kind of what we're focused on capturing and codifying in our software, so that that can be possible.
Now, how does that work? Because to me, it's usually these factories try to sell you, like you said, on the MOQ, because they have to set up production line and they have to plan everything. And obviously they give a bigger break on the more you get, because of course they get better deals on those supplies, right? It's all based on amount you want and also how long you want to have your contract, because they'll take pennies on the dollar if you're going to order like 1,000,000 of them. But if you're ordering like 5 to 10 or even less than that, they're going to want some more money because they have to deal with all this other stuff, right? So how is it that you guys are able to do this?
Yeah, so there's been a lot of progress outside of what we're doing on the physical automation side of things, sort of more general purpose robotics. Obviously, that's still an active area of development, but we see that as that progresses, it should be the case that you can, obviously within some constraints, have a setup with robot loaders for the machines and all that sort of thing, have all of that stuff automated, which is very capital intensive at the moment. And because of the human side of the thing, it's not efficient to set up unless you are doing those sort of massive jobs where you're going to be making millions of dollars from one contract. We see it as if there is the reduction in the human input required to get from design to manufacture, then that starts making a lot more sense financially for these smaller businesses to invest in the physical automation stuff that's very expensive, but once it's there, it's there. And people aren't doing that because they are sitting idle, the machines, and thereby the robots that would be loading them, and you've invested all this money and you're not really seeing any benefit because you're limited by this human factor. We want to help the humans that are there to operate the machines 24/7, basically. We don't think we're going to replace every human manufacturing worker anytime soon, but we want to make it so that that machine can run all day and be making, because these machines are between $100,000 and $1,000,000, depending on the size of the machine, whatever capacity it needs. So we sort of want to assist the humans in the process to make it so that these local businesses can compete worldwide.
Sense, yeah. Now, when you guys started off making this software, actually, I'm kind of curious about, because you said 3 co-founders, right?
Yep.
I think that's the part when things start to get a little bit more difficult, because instead of 2 heads, you got 3 that are going different directions, right? The more co-founders you have, the more it can be to make these kind of decisions, right? So who had the idea first? Let's start with that. And then how was it to come together to some kind of consensus to say, okay, let's do it?
So the machine shop idea came from me, and it also kind of started as more of a hobby project. I was going to build it in my friend's garage, who's another co-founder, which the scope quickly grew out of proportion for that. So we ended up renting a workshop space and building this several ton machine over there. And we ran that for 9 months or so before we decided there's a better way to solve this problem. And then we really spent a long time sort of ideating on the best way to do that. The better part of a year, probably. We played around with a whole bunch of different approaches, because the pain we felt most acutely was programming the machine itself is one massive area of difficulty that we just really didn't expect. It's like fancy machines exist, it still requires an expert to operate them. Feels strange. Like, it makes sense that someone's got to put the block of metal into the vise and tighten the handle, but the fact that the machine can't just like take a 3D model and hit go and make the thing once the thing is in there, like the block of billet metal, that was a surprise to us. So that was where we were originally focused on trying to solve that, and we sort of played around. For the record, actually, none of us knew Rust before starting the company. and we were kind of just playing around. I've got some experience with C and C++ and Python. One other co-founder's C and Python. The other one is non-technical, more business focused, and we were sort of building these pretty crappy prototypes using those languages and realizing pretty quickly that we'd bitten off a bit more than we could chew, particularly with three of us at that time. So sort of started trying to limit the scope down as much as possible. And it was a slow but I think generally productive progress where we came to where we are now, which is the core idea that you can't automate the manufacture of something that can't be manufactured in the first place at the end of the day. So what we're targeting now, first and foremost, is helping engineers like myself when I was just out of undergrad and working at this other startup to design parts that can be made. And that can take a few forms, but fundamentally it's basically, we call it design for manufacture, or DFM software. Spell check for engineers is the metaphor we use. And yeah, that's what we're working on at the moment. And we see that going further into the automation space as we sort of nail down the correctness of that aspect.
How do you guys even get clients? I don't know. I for so many other things I can understand Google searches and things like that. But these kind of design things, usually they're so, I mean, of course, no offense, but like my understanding of design and manufacturing at least is like so old school that maybe you have to really like pick up the phone and start calling these kind of places and saying, hey, would you want to try this thing out? Is that kind of the route that you guys had to go in initially? Because it's such a, number one, it's very much a vertical, right? And the other one too is, yeah, it's an old style of doing a lot of things. I think a lot of older people are still running these kind of factories. But I guess now is the time when younger people who want to do a better way may be starting to look. Is that kind of helping out?
Yeah, you're 100% right. It is very old school. There is a big issue that's sort of on the horizon / the pain is starting to get felt now of a skill shortage because not as many people are going into trades. There aren't the experts required. Most in Australia here, I'd say at least 50% of the machinists that we've met have come from overseas to work. Primarily India. There's a lot of really good machinists that come out of India and work here because there's just so many jobs here for it because no one's doing it, which I think we really fit in well there because there's a skill shortage and we're providing the expertise that is currently lacking. What our actual approach is at the moment, because we did initially start trying to target manufacturers and engineers directly, we're more focused now on procurement companies, which sort of act as a marketplace between people that want to get stuff made and the people that make them. So we've talked to people, there's none in Australia actually, but we've been talking to some people in Canada, some people in Singapore. I think we've got some conversations lined up with one in Germany and one in Israel, I believe, this week. That's for us the easier point of entry because they're already offering there's quite a lot of these sort of companies and they have varying levels of design for manufacture stuff in there because they've got to deal with the fallout when they provide an instant quote for something and then the manufacturer calls them up being like, I can't make this. And then they've got to deal with talking to the engineers and being like, well, that quote wasn't accurate. If you want to get this made, we're going to need to go find someone else and they're going to charge you more. And it's basically a shit show. So it's kind of an easier sell for us. And it immediately gives us a much bigger outreach to both engineers and manufacturers who are using the platform. So that's kind of the strategy we're going with at the moment.
Yeah, that's interesting. So then would you also be reaching out to places like Alibaba? But I thought those places are usually that people list their things and then you buy them. I don't know if I never used it, so I don't know if you can actually solicit for quotations or something for manufacturing small amounts of something.
I'm not sure if that's a possibility. And at the moment, because most of Chinese manufacturing is very much high volume, right? We don't see our value proposition being as high there. When I was working at the other startup doing design and stuff, we did end up going to China to get stuff made because the Australian manufacturers wouldn't have the time of day to deal with the early stage of the company that we're at and the flaws in my designs personally. They kind of just either don't reply, give you a crazy high quote that's just unreasonable, like one prototype little plastic enclosure thing's like $500. It's ridiculous. So we did end up going to China, and they're extremely professional. As long as you can say, yeah, we're going to order this many parts, they're extremely professional. They will put engineers on sort of the job to help you work through that stuff. They've really got it set up in such a way that they've got the expertise there and they're happy to provide it as sort of part of their value proposition. So we think it might be a bit hard for us to sell there. In terms of Alibaba, I haven't really looked into it, to be honest. I've used it a couple of times just for ordering random stuff, or AliExpress at least, and I haven't seen any mechanism for that sort of process. But interesting avenue.
Yeah, I mean, they have huge connections to factories direct, right?
For sure.
I don't know, like I've never used it. All I know is that you can buy stuff wholesale.
Yeah.
It would be an interesting segment to get into to like upload designs and maybe get bids, etc. Yeah, and what you said about the manufacturing, yeah, I mean they should have quite a bit of expertise because they've been the world manufacturing hub for quite some time. But I can imagine like even in China, they may want to consider to even use this software because no matter what, salaries go up.
Yeah.
Right. It's getting more and more expensive everywhere. Nobody's like getting cheaper as far as I know.
Mm.
And I know my cousin used to work for, I won't say the name, but it's one of the big phone manufacturing places. And he would tell me like every time they go to design and manufacture phones, like he would have to have a meeting with all the suppliers. And it was like starting from day zero, like they have to, okay, come on, guys, we have to. This is not the first time we've done a phone. Okay, we had to get the semiconductors. We got to get, like, it was just funny, like to hear his side. And you'd think that they're quite professional. I think maybe they are to a certain extent, but there's also like, the people that are actually doing the manufacturing on the line are not the most experienced with this, and they may just be seasonal or whatever. Because, you get like weird things where people are like touching their face, maybe just a scratch, and then they touch the glue on the screen, and then it goes on and it doesn't stick on because the oils on your skin will like deteriorate the glue. So yeah, there's a lot of weirdness when you're creating stuff.
Yeah, for sure. I think that in terms of the people on the production line, it's very interesting because it often depends on how critical various aspects of designs to the process and conveying that to the person on the shop floor actually making the thing in terms of, is this surface something I should not be touching, for example, or is this exact dimension of this spacing between two bits of the part really critical or not so critical? And those things, if they get lost along that process, and this is something we're really planning to try and supplement and facilitate better communications as well with, is very easy to have this seemingly great process, and then at the end you get the part and it doesn't fit in the assembly, or it doesn't go together properly, or any number of issues that can take place purely from a lack of communication, even within the machine shop. But especially if I've got an engineering drawing and in my CAD file there's a bearing or something that's press fit into a hole or whatever exactly it is, if that information, the context of the greater purpose of various features on a part isn't conveyed all the way down, if it gets lost at any point, then it probably won't work. And then you've got this whole issue of having to figure out who's to blame. Is it my fault for not tolerancing the drawing? Is it their fault for not giving the drawing to the person on the shop floor? Or where is that breakdown in communication happening? And one of the tools we're sort of working on at the moment is specifically that, communication tools using 3D models that everyone has the same access to. So if I'm the engineer, I can stick in this part of the model is really critical. Even if everything else is out of spec, make sure this bit is. And then if the people who are doing the quote, the people who are doing the actual manufacturing of it, the people on the shop floor, the assembly people, if it's a big operation like that, if they've all got access to that information directly and they look at it, rather than having these printed out bits of paper with drawings and then probably hand scribbles and phone call being like, oh, you missed this dimension, do I care about it? There's a lot of margin for error in the current process that we really want to iron out.
Well, there's that, but I'm just thinking like, I always like to think what do you call that? I always like to be the devil's advocate and just think about the other side, right? The people working on the line, they aren't usually paid the most and they're not always the most educated or even motivated. So would they actually even care to look at these kind of things? Or, would the factory even bother to train them? Because there's quite a bit of people who just don't get trained properly. There's quite a few, like, I mean, I don't know how service industry is in Australia, but in US we're known for pretty decent service, right? Because we have this big tipping culture, right? So if I
Yeah.
don't treat everybody nicely and give them a fake smile, then I don't get, extra few bucks. I just think over here there's just not good training because it's like, well, there's no motivation for that, right? So what's the point? I guess do enough that you kind of keep your job, right? There's always that. And like the other thing too is like sharing those digital designs and the comms and everything, that's also an investment on the factory side. One, do they have the margin? Because I think manufacturing of hardware has become low margin compared to software. The other thing too is like sometimes they just want to keep a few extra more bucks in their pocket, or, especially with China, right? You should be getting like pocket of money from the factory. You have like 100 employees, it's quite a bit, especially some of them. I think 100 is probably a little bit low for this kind of stuff. And also bonuses, salary itself, costs of material, costs of everything, and just yourself to pay yourself, right? It's like there's so many costs. It's like, do I really want to invest in this kind of thing when, we've been doing things a while for this other way? Is it really worth it? That's like, how do you sell old school way of thinking with these new ways of stuff? Like you'd have to probably show, okay, this factory implemented the comms or this thing, and this is the reduction in savings, right? Sure, there's this investment, but over 5 years, it's going to be this return. Are you doing something like this when you do this kind of talk?
Yeah, so at the end of the day, with your example of the shop floor person either doesn't care or they're not trained or whatever else, resulting in something not being right. For one, we're aiming to make this something that requires less training than the existing process. But more importantly, every time that happens, especially in high volume, you are basically maybe you make 100,000 units of something and none of them are right because there's been this single oversight somewhere. The person that has paid you to do that is not going to stand for that. You're going to have to make them again. That's a huge, big red negative number on your bottom line. So if we can catch that stuff, even before the design gets to the shop floor, is kind of what we're aiming at. We want to make it so that things are less subject to failure as much as we want to make it so that they can be made. If there is something that we know is going to be really, really requiring very tight inspection every single time a part's coming off the line, then if there is a way that we can advise the designer to adjust that design in such a way that it means that that tolerance is no longer super critical, that means that maybe even if the shop floor is making mistakes or whatever, it's still going to work in the broader scheme of the thing. Because it's fundamentally, if you've got something that's critical like that, there is a higher margin for error, which tends to come with an increased cost. Tolerance is a massive cost driver, going off that example. So we broadly think that all of those issues you described, we're kind of aiming to solve by various means. So making sure that the design itself is less subject to these sort of things, because those always drive the cost up. Because someone who's good at quoting those sort of jobs is going to pick that up and say, this is going to have either this amount of risk for us that we get it wrong and then we have to remake it or whatever, or it's going to require so much inspection that I'm tripling the man hours required to make each single unit. So that gets factored into the price, which if we can advise the engineers designing the parts that this feature or this tolerance or whatever it is going to triple the cost of your part, maybe you're going to change the design a little bit. Because often these oversights are really, really small. Like just putting a hole at a slight angle is an example that we often give, where if you've got every feature on the part can be accessed from one direction and you tilt just one feature by fraction of any amount of degrees, and that's on the 3D model, skyrocket the price because of all the inspection stuff. If you specified 3 degrees, they're going to try and make it to 3 degrees, which means
I'm just thinking in my head, like, is it possible that, you can send a design of a factory and then they'll say, oh, we cannot do that. But if you make this tweak, then we can do that because, like you said, these machines are they're somewhat rigid, right? Like you said, not every factory can do all manufacturing.
yeah.
You need specific machines for specific things. So is it possible you can submit a design and they'll say, oh, we took a look at it, we can't do it, but if you move this over here, then we can do it. And actually it's going to be this price or whatever, right? Would you ever have something like this kind of back and forth?
Yeah, and that's a big focus of the communication aspects of what we're building, because the current status quo is basically either they don't want your business enough to bother to do that, in which case you're going to just go find somewhere else. They don't have the time or the man hours available to give you that feedback, or they just otherwise don't care, but they still want to have a shot at making some money, so they just double the price of the job and they'll make it. They'll figure out the way, because at the end of the day, you can make anything, broadly speaking. There's some exceptions, but if they're like, oh, we could work around this and we think we could still make a solid profit if we just 2x the price of the part, and if they accept it, whatever. If they don't, whatever. Or if they want the client, then we've talked to manufacturers that have put together 50 slide PowerPoint presentations with either like photos of the engineering drawings or the 3D models with like hand-drawn annotations going through like every single thing that needs to be changed for them to accept the job. And then if they do all that, then this is the price we'll give you. Otherwise, like, go find somewhere else to do it. So it definitely happens, and we really want to make that way easier so that it doesn't need to happen right at the end when you're at production or prototyping stage, where design change is costly, because changing one part means you need to change the part it's attached to, change another one, and you get all these downstream effects from making changes late in the design cycle. So we definitely want to get into the engineering shops earlier in the process. That's on the shelf at the moment because we're focused on procurement. So it's more about, go essentially like, this thing we know that none of the manufacturers here can make this. You need to change it. But it's definitely something down the road we want to be focusing on.
It'd be interesting to actually even reach out to, or to submit your design to like the company that has those machines, and then somehow I could figure out which machines can fit, and it gives you like a probability match against which factories have those machines, and say, okay, why don't you try these guys? That'd be kind of funny and interesting.
That's kind of exactly where we plan on going, because obviously there's different rules for different manufacturing methods, and different shops have different machines. So it's definitely a logical follow-on. But in order to detect what the errors with a part are, even if we're told, hey, drop down box in the procurement platform, I want this CNC machined or stamped or sheet metal folded, laser cut, whatever, we need to compare the options in case they select the wrong box and we're saying all red, everything's wrong, but then another manufacturing method, it's like perfect. We don't want to be doing that, because that's not good for business for the procurement company if every model you stick in's telling you that you're a terrible engineer and you should feel bad. So yeah, we basically need to detect what method is most likely to be used to manufacture it, and then you can sort of do a bit of a fit with the different types of machines that people have. And we don't necessarily have access to those databases on the procurement side, but we can provide the sort of infrastructure layer underneath that they can apply that business logic to their exact use case, depending on who their vendors are.
I'm also kind of curious about the comms part, because I've lived in China for quite some time. Now I'm in Hong Kong, and the English level in mainland China is not exactly the best. So do you have some kind of translation problem, or sorry, not problem, but solution, or how do you handle these kind of different language issues, or is this not an issue at all?
Not at the moment. We've only ever really, in terms of the state of the software at the moment with the communication stuff, it's been sort of very beta version. We've been primarily sort of testing it out at university machine shops where they have students that get stuff made for projects and whatever. So for dealing with that, because students from experience are pretty bad at designing parts that can get made. So they were sort of a adopter in a sense, where they can use the software in a much lower stakes environment than these sort of mass production scenarios. And obviously being in Australia, we just went across the road to the uni and was like, hey, use our stuff. One of my other co-founders actually gave a guest lecture at one of the unis about design for manufacturing, that sort of thing. So that was interesting. We haven't really thought about the language issue to date. The assumption's somewhat been that procurement platforms themselves handle most of the customer interaction things. And if it's the case that they've got someone from an English-speaking country speaking to someone from German or Chinese or whatever language, that maybe the translation layer lies in there. But we've been more focused on the smaller platforms to date that are much more local. So it's not been on the radar that much. But we'll probably end up just using Google Translate or something like in the meantime.
I mean, I don't know about for sure for Chinese. I mean, there's a lot of Chinese moving to Australia, so it should be easy to find somebody, or even studying in Australia.
Yeah.
I think one of the biggest money makers for the Australian government. I think Australia itself, the economy is actually Chinese. I like people studying abroad in Australia and buying up property, etc. Is what I hear. I don't know what the truth is.
Yeah, sounds about right.
Yeah. But yeah, as I say, you can always go the what I call the Adobe route, which is like super cheap or free to universities. So when they graduate, they'll say, well, I only know this software, so we're gonna have to buy that, or else I don't know how to use the other one.
That's definitely our plan.
That's a good plan. I mean, it works.
Yeah.
I think that's how Adobe has such a stranglehold in the market. And then you go the MRR, monthly recurring revenue, like every month costs X amount. Then
Yep.
you're really in good standstill. We've been talking so much about your domain. I hate to have a Rust episode with no Rust in it. So
Yeah.
what happened that you guys started looking at Rust? I mean, I know it must have been a C, C++ thing, I'm guessing, because that's such a tricky language to work with. Is that what started the whole Rust conversion?
Yeah, so I was recommended it by the CEO at the company I was working for, just sort of as, hey, you should go play with this. Not necessarily, hey, you should go write everything ever in Rust. But I did play with it a bit, did a lot of reading. In our industry, intellectual property is like these CAD designs are basically like source code at the end of the day in terms of IP for engineering companies. So it's super critical that things are secure, for one. So the whole memory safety thing and type safety that it gives compared to basically most other languages, that was a huge driver. And we did some very surface level investigation on does it have enough libraries and those sort of things for us to build on top of that it will serve the purpose, because it obviously is very young compared to C++ or Python or C or whatever. And the one sort of thing we were concerned about mildly was like parametric design support side, which in retrospect, I think the lack of support there has been quite good. There are some really good, very interesting projects to try and build a CAD kernel similar to OpenCascade is the sort of incumbent C++ CAD kernel open source runs. FreeCAD is the primary example of a CAD program that uses that as their kernel. We looked at that and basically hated it. So it has all the issues associated with some very old software that's written in C++, this massive library, and it's very difficult to even get running, and jumping into Rust is just like such a smooth experience. And being able to, because what we're doing is we're not fundamentally a CAD design software, particularly like a boundary representation with NURB surface like Blender. We're not for design or for scene modeling or for animation or anything. We're trying to find features in this 3D model data which pose problems as it relates to specific manufacturing methods. So having a clean slate is actually good for us. We don't need all of that baggage associated with the way that it's been done before. So having no really solid, stable libraries to build on for that has actually been really good, because last year we spent a couple of months building a sort of MVP version of the design for manufacture stuff for CNC milling, and we basically quickly outpaced all of the, at least as far as we can tell, uploading designs to various platforms that have some DFM. We were better than that in 2 months because we had this clean slate to build on. So that's been excellent. And honestly, I just like, we weren't always fully Rust. It was like Rust on the back end, TypeScript on the front end, whatever. Then we came across Vue, had to play with it, had our TypeScript guy learn it, picked up Rust in like 2 weeks, just in that sort of isolated environment framework, and it had a functionally equivalent version of our sort of product website done in that time. And it was like, let's just make everything Rust. There's still, because we're more focused on integrations at the moment, we don't actually use that exact product SKU at the moment, which is more of a full platform. We're just really focused on the renderer and the communication stuff and visualizing the results of DFM, which is in Bevy. But we do intend to go back to it, and we'll probably reassess whether or not we should be still using Vue as opposed to something that's more stable and established like React or Vue or whatever. I'll be lobbying very hard against that. See any particular reason to not just do it? Because sharing types between the back end and the front end and stuff is really nice. It means we're never worrying about API changes breaking compatibility with our own product or whatever. Like everything's sort of drawing from the same repository, I guess, of truth, which is amazing. Yeah, Rust is excellent at the end of the day.
Yeah, that you mentioned quite a few libraries already, right? You have Bevy. What else are you using?
Bevy, all of our sort of core geometry analyticsy stuff we've written from scratch, like I said. For web framework stuff, we're using Rocket at the moment with a sprinkling of Actix Web because we needed WebSocket servers, but otherwise found Rocket was a bit more friendly to use. Although now we're using Spin for some microservices stuff, which is amazing, actually, as a result of listening to this podcast. So the reliance on sort of larger, heavier API servers and stuff is reduced a bit from that. But that's about it, really. Like the core thing we're working on right now is getting integrations nailed down. So that's a matter of having our Bevy renderer with all the bells and whistles as something that we can embed on JavaScript, TypeScript websites, then just the bare bones minimum API so that the servers of other companies can basically send us a model, we analyze it, we send back the results, and because of the IP sensitivity stuff, we're not saving anything at the moment, so it just gets dropped from memory as soon as it's done and spin down, I guess, and that's that. So it's pretty straightforward relatively. Obviously, there's all the sort of custom built stuff in terms of how do we pass step files, how do we then construct this data model that is effective for us to analyze this sort of abstract CAD geometry in a way that makes sense and lets us have a high degree of certainty that when we say this can't be made, we're right, because we don't want to be throwing errors to someone who's uploaded a part to a procurement platform. So they then go and either just stick it in another platform that's like, this isn't a problem, whatever. Unless when they do that, they get a response from them being like, actually, we're not going to be able to make this. You need to go change the exact same thing we pulled out. We basically need to be right because otherwise we're sort of doing harm to the businesses we're integrating with. So that's another benefit of Rust, I guess, like having the sort of happy path defined in such a way that it's almost a state machine. If this and this and this, then we're certain we're not wrong. Go fix it. Or yeah, basically the ability to codify rules in such a way that there's certainty about what we know and there's certainty about what we don't know gives us a really easy set of things to work on next because we know the solution space we're in.
What I actually found quite interesting is you guys are using Rocket. I don't know of any other company that's at least been on this podcast that's using Rocket because Rocket's kind of, what do you call it? It's at a standstill at the moment, right? I think the last update was May of last year. Well, last year was 30 days ago, but yeah.
We started using it just after the RC2 for 0.5 was released, hosted, whatever you want to call it. So it was being worked on then. And we actually, the very first thing we did in Rust, not knowing anything about it other than like sort of skimming through the Rust book and reading Rust for Rustaceans and that sort of thing. The first actual code we wrote was a web server in Actix Web, and it might have just been that we didn't know Rust well enough, because we definitely didn't. But we found at that time that Rocket was much more friendly for people that didn't know what the hell they were doing, basically, in the language. So we switched over to it, and it really doesn't do a lot of work. It's just sort of basic routing and calling other external functions, and we've only recently started playing with Spin, but that seems like it's probably going to be the way forward. It's really nice because we played with Kubernetes a little bit as well, sort of more toy applications. We haven't really had the server load to need it, but we're kind of moving in that direction. And yeah, the API itself doesn't do a lot, so we're not really coupled to it, but it was the choice we made at the time, and it's done its job. So we're keeping using it until it stops doing its job. And it is a bit funny. We've got the random little tiny Actix Web thing, which is basically running a slightly modified version of the examples WebSocket server, just to fill in the lack of WebSocket servers in Rocket. That's a bit awkward, but other than that, it's been fine.
Now, what made you decide to use WebSocket approach? I mean, because you have to like tack on an extra service, right?
Yeah, it was just for the live chat functionality, so like two people could view the model and annotate like faces or whatever being simultaneously. So all it's doing is just like you log in, you're on the thing, you open a model, it then puts you in that WebSocket, and then if someone else creates a new annotation, it just pings you saying, hey, hit the thing that gets the latest version of the ledger of all the chat messages. It's a super hacky workaround, but what are you going to do? It does its job for now. We're probably going to do a bit of a refactor of that, but yeah, it was such just a small feature to add that it was easier than rewriting everything in Actix or figuring out a different way to do it.
I can almost imagine doing like poll-based kind of system rather than WebSocket, but because I don't know how often these designs are going to get updated. I suppose a lot in the beginning and then even less later on, right?
The idea wasn't about the model changing, it was more about, say you're the manufacturer and I'm the engineer that's designed it. He maybe sends a message some way. We don't have an app or anything, so there's no push notifications, but he somehow gets in touch and is like, hey, I want to talk about these things on this model. We just wanted it to be like LinkedIn or Facebook or whatever, where the thing is always exactly like ping, you've got a new message. So it was just like instant update. So as soon as that does that, it just broadcasts a message in the WebSocket like chat session that is linked to that model. And then it's like, hey, go, you've got a new message, go pull it from, go hit the other endpoint. Acknowledge it's super jank, but it's currently not actually being used at all, but it's still live.
Okay. Yeah, that's interesting that you brought that in. Actually, I don't hear of a lot of people using WebSockets within Rust. Maybe I'm just asking the wrong people, but it's like nearly nobody's kind of talking about it. I don't know. Maybe it's because Rust is so quick and maybe not everybody needs that kind of like, instant feedback. Like, okay, is this thing, do I have the message in right? Not everybody's doing chat applications anymore.
Yeah.
That's so 2020, I guess, to do chat
Yeah.
applications these days.
Yeah. They could just be using WhatsApp or Facebook Messenger or Slack or whatever, but
Yeah.
we felt it was such an easy thing for us to do that we just sort of tacked it on there. It was more of a tech demo thing than a actual thing that's in product at the moment, but
Okay.
may see a comeback at some point.
I guess you haven't mentioned it. So I'm probably going to think about like actually redoing everything in Actix Web or something else because you already brought in Actix for a piece of it for that WebSocket part.
Yeah, potentially. It depends on if there's a need to. The existing code base is fine. It does, other than that, everything it needs to. If we're looking at doing a big restructure of the API in any way, we will definitely consider it because it's the live chat thing is probably a feature that people are going to want. Either that or an easier solution would probably just be integrating with third-party chat applications in some way. But yeah, that sort of part of the product is shelved at the moment in terms of development because there's only 5 people in the team at the moment. We're currently hiring, but we need to focus pretty heavily. So we've gone down this integrations path. We're really working on that because we've got a pretty good structure for all the Rocket API stuff. There's not really any reason to rewrite it, and we're not integrating the WebSocket at all in the first version of this. And at the same time as well, we're using Spin as much as possible so that we just are routing requests through our API to make sure that the keys are authenticated and it's coming from the right server and whatever, and then sending it off to those microservices and sending them back. And we're not storing any data. We're not doing anything particularly complex. So it's not a huge business case for us to change what works at the moment.
Yeah. Well, the only thing is like if Rocket becomes a problem where, something's not working anymore or whatever.
Oh, yeah, for sure. It's something on the radar to keep an eye on, but we're still very early. I should definitely clarify that. So there's room for a little bit of hacky things going on, and rebuilding stuff that works is too much of a time sink for us at the moment.
Now, I mean, you're using Bevy, right? That's probably to display like a 3D of that
Yep.
thing that you want to build, right? Okay. Now, has that made people in the team interested in making video games?
It's made me interested in making video games.
Yeah.
One of our staff has played around, I think, in Unity before, and I think it's reignited his interest in making video games, but obviously in Rust. It took all of us quite a lot of getting it because we're not really game developers. He's probably got the most experience and was just making like 2D sort of indie game sort of things. The ECS, the entity component system, is really weird, and I've not enjoyed the coming back to some runtime errors that's associated with it, which in terms of all of the server-side code we've written, it's like if it compiles, it does what you told it to. Whether or not it does exactly what you wanted it to do, that's up to you to test it properly. But going back to Bevy, and it's like, why is this just crashing randomly? Has been interesting, but we've got to head around it. We've only picked it up sort of the last 4 or 5 months, I think. So it's been fun. I want to make some video games now. I think a lot of us do. And there's actually, because we're hiring at the moment, it's been interesting who sort of comes out of the woodwork when we post job briefs with sort of Bevy as part of the stack, because we've had people that have like contributed to it and stuff who are local to us in Melbourne, which is super cool. We kind of just assume in Australia, like, there's not a lot of people working on that sort of stuff, but turns out there is, which is awesome.
Speaking of hiring, right? How is it to find talent in Rust? I mean, is it that you're finding most people just never even heard of it or have never probably worked in a professional way, I'm guessing?
Yeah, definitely. There's not many in a professional way. I think there's not many companies using, certainly not 100% Rust. There's always going to be some sort of JavaScript in there if you got a website or something. But the biggest challenge for us, I think, is we are trying our very best to hire locally only because we have not been particularly effective at managing remote work very well. So working in person is kind of a requirement at our stage currently because there's a lot of sort of high level design conversations and stuff that are really hard to have over Discord or Zoom or whatever. Sit down for half a day and just like shoot the shit about how we're going to build the thing is really difficult over the internet. So that really limits the scope of the number of people that we've got available to us. But like I said before, there have been some really good applicants, which is amazing. And I think Rust itself is almost a bit of a filter for applicants. Like the last time we hired, or the time before that in particular, when we were still sort of learning Rust, we didn't really advertise the jobs as Rust forward as we do now. And you get a lot more applicants, but the mean quality, I think, is lower, which is good because it's less work for us filtering them. It's like the people that apply are quite clearly into it. A lot of them have got either tons of personal projects they're working on, or they've like contributed to interesting Rust project, or even Rust compiler itself, which it makes the job of hiring a fair bit easier when all these people are quite clearly very passionate about the programming language itself. And often it's like, I've still got a job, but I was just like on Reddit and saw that we posted on r/Rust or like Rust who's hiring or whatever. And I was like, I could go and get a job writing Rust instead of whatever I'm currently doing, which is awesome. Like, because I'm on that same bandwagon. Like, I really hope the company succeeds and we do amazingly, but I'm scared that if we don't, I'm going to have to go and use a different programming language, which I don't want to do. Just start another startup, I guess.
Yeah. So you take Rust with you to another startup or to a new company if this doesn't work out?
I do my best to. I tried to write some Python the other day, and I'm convinced that it's more difficult than writing Rust. I sing its praises.
I think like Rust is almost like when you're using Rust, I don't know. Like I watched this guy named Larry Lawton a lot on YouTube. Was a big jewel thief, and he talked about like the first day he got out of jail, like not the first day, but sometime soon he went to eat with his friend, and his friend gave him the menu of the restaurant. Was like, order anything you want, and he's so used to this is the food you're going to eat. You don't have a choice, right? And he's been doing it for like, I don't know, 8 or 10 years. So it's like with Rust, once you finally have the ability to write whatever code you want in Python, you kind of miss having like Rust telling you, no, you cannot do that. Or yeah, that's okay. Like all those kind of rules that you just bend over for or whatever you want to call it, like come around to. So I can understand like, well, I don't know how to write this, or I don't know. Yeah, I feel weird not having somebody telling me I'm wrong or I'm doing it right, or the Rust analyzer running in the background saying yes, 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 no, no, that's not right.
Yeah, even stuff as simple as like, how big is this NumPy array? There's no way to know. It can't be known. You have to know at runtime, which is confusing. I want to know when I'm writing the code.
Yeah.
how many dimensions my array has. Like super simple stuff that you end up taking for granted when you write Rust every day. That I guess for simpler systems are probably fine, but even writing scripts and things, I just use Rust now. It's probably the only programming language I'm proficient at anymore, because if I went back to anything else, it would be a steep learning curve to get back into the mindset of, oh, these things are fallible and I don't know they are, or whatever else is wrong. Yeah.
Speaking of getting into like a programming language, right? So most of the people, I mean, they don't even have Rust when they come in. So how do you actually upskill them or try to get them into Rust? I mean, how did it work out for your front end guy? How did he get into it?
So the front end guy is one of the founders, so he's been here since, and alongside the others learning it. Another one of our hires is very experienced in Rust and basically went a long way to teaching us how to write Rust properly. And he was the most recent hire. So more recently, we are advertising for a front end type position with someone who's sort of got UX design experience and more visually inclined, because we're all very engineering-y, I guess, when it comes to UI UX, and we can make it work, but we don't really make it so good. So for that job, we're not advertising the requirement of any Rust experience. And I think the plan is going to be to have them come on and basically work alongside someone else for a week, 2 weeks, however long it takes, so that they get the feel for, at least for you, because it is very similar to React, TypeScript React, so I don't think it's going to be that much of a challenge. And in terms of the more back-end software engineering-y type roles, all of the people we have, I believe, currently at sort of the technical interview stage, all have Rust experience. So yeah, I guess we've been lucky to get applicants that are interested in working for us that all already know it. But the front end is going to be interesting for sure.
So when you had the person join with more Rust experience, was it like you had the Rust compiler helping you, Clippy, and then finally the other guy who gave you even more? Kind of
Yeah.
like, no, you can't do this. You should do it like this.
Yeah, just like simple stuff like, hey, stop using for loops and use iterators, or don't ITM initialize then mutate. Do it this way instead. Like just more idiomatic patterns and those sort of things, which turn out to be a way nicer, cleaner, better way to write code. So he kind of, his first, I want to say month probably, was a matter of going through all our code and explaining to us why it was bad, which is great. Like, I love learning all of the nuances about why things are better in the language, like better ways to do things in the language, whether it's compiler optimization or readability or reliability or whatever else it is. Like, learning that stuff is super interesting to me and the others, I think. So it's been amazing having him aboard.
Oh, that's great. I mean, I don't have very many more questions, and we're kind of reaching. We actually went over our time, but
Yeah, no problem.
I think somebody who has like all invested into Rust, right? Do you have any advice for other companies that may be considering the same thing?
I would say pick your battles. It's definitely not the right decision for every company. If you're writing everything from scratch and the core part of your IP or value proposition is something that benefits from a less mature ecosystem with a substantially better programming language, no offense, other programming language, or some offense, like we really benefited from not acquiring the baggage that other frameworks already had, because we're building something that is fundamentally different to that use case. So having just like, this doesn't exist, let's write it, was really good for us. So if that was the case, absolutely. But if it is a solved problem and there's just like a library that exists to do stuff that doesn't exist in Rust, it's probably worth, at the very least, doing some like language interop or separating them out into different complete binaries and running them separated. So if there are problems with it, you can replace it, like drop in replacement with something you've written. You got to focus your development, especially if it's early, like on things that really add value and differentiate the company itself. So if that means writing something that doesn't exist, or if it's a matter of plugging a bunch of stuff together and providing some special interface or whatever, I don't know, maybe it's not the right choice, but for us at least, I think it definitely was.
Okay, and with that, I thank you for coming on and talking about your guys' experience and I think now everybody has got some, maybe an associate's degree in manufacturing now. A lot of stuff we had about manufacturing.
Yeah, it's great to be able to talk about the problem in that sort of level of depth, because often when you're given like a minute to like the elevator pitch, as they say, it's really hard to convey all the nuance. And I really appreciate insightful questions on especially the manufacturing stuff, but across the board, it's been great.
I think I'm a firm believer in like technology is not usually the problem. Usually people are the problem, or maybe process or something like that. Usually it's all boils on the people, right? People make process. Process doesn't make itself.
Yep,
So that's usually the more interesting part to me.
for sure.
All right. And with that, thank you for coming on.
Great. Cheers.